appreciate the opportunity today just to share with you some of our experiences utilizing the electrostatic particle ionization program. What I'd hope to accomplish today is introduce you to the EPI technology. How has it been used? Does it have application to the swine industry? How did it perform under controlled commercial research conditions? What does the payback look like? And how do we plan to use it within our system? So, just to kind of give a little bit of background on what electrostatic particle ionization really is. EPI, essentially what the system does is charges the airspace in confinement livestock buildings with 10 billion negative ions per second. What happens is those negative ions polarize particles in the air, causing them to attract many surfaces, thereby removing them from the air. So if we tend to think about odors, gases, and pathogens that readily attach to those particles, you can see where you potentially would get some performance improvement from that. In essence, what really happens is ceilings, walls, gates, light fixtures, heaters, etc. become magnets in the truest sense for these charged particles. Just to give you a little background of what the system looks like set up into a confinement building, you've got a series of power banks. This photo is actually a little bit dated. There's a kind of new and improved set of power banks that allows you to track time on, time off, and along with the output. This is what it looks like inside the building. There's a series of these corona points, so there's lines that go down the length of the ceilings of the buildings that are spread apart equidistant in the room. So you see kind of a picture of the clear corona discharge points right here. And then when the system's turned on, what you'll see over time is you'll start to get the dust. Those charged particles will collect on the surfaces around those corona points. And if you would stand, I couldn't find a good picture really to represent it. If you took those corona points and drew a 2-foot, 3-foot diameter, you'd see a ring that would be around those corona points, where all those dust particles have clumped together and have been attracted to those surfaces. How has it been used? How did it get introduced? Initially, the EPI technology was used in smokestacks in an effort to trap particulate matter and reduce emissions. The initial agricultural adoption were in poultry facilities in an attempt to improve air quality. While in some of those facilities, some USDA researchers confirmed that the EPI system could remove 60 to 80% of the suspended particulate matter from the airspace. So really the question is, hey, that sounds good, that looks good, but if that doesn't translate into pig performance, that doesn't help us out a lot. So really our primary question is, we were certainly intrigued by those results, but would that reduction in the suspended particulate matter translate into improved pig performance? So a little background on how this evaluation was designed. It was on an 8-barn nursery site. The EPI system was installed in 2 rooms in each of those 2 buildings. There are 2,200 head nursery rooms, conventional negative pressure style ventilation systems, slight differences between the 2 in how air came into each of those buildings out in Utah. So each barn had 2 of the 2,200 head rooms. The EPI system was installed in 1 room and the other room was left as a control. And each of these barns, the site fills 1 week from 2 different 5,000 southbounds. So essentially it's all in all out by barn and continuous flow by site. So a little background on the design. The evaluation started in April 2009 and essentially ran for 1 year, or 5 consecutive turns through those 2 buildings. Performance, gas, and dust measurements were taken during each turn in order to calculate average daily gain and percent mortality differences. We looked at hydrogen sulfide and ammonia levels between the 2, and also looked at dust particulate matter. The growth measurements were generated by weighing 32 pens in each of the nursery rooms, both shortly after arrival and shortly before those pigs were shipped out, in order to get an accurate weight at entry and exit for the average daily gain calculation. So essentially 50% of the pigs in those rooms, that information was pulled together into a room average. So essentially we had 10 room turns per treatment. So let's talk a little bit about the results. What we saw when we took those 5 turns and pooled them together and did the statistical analysis was we saw an 11-point improvement in average daily gain, which essentially translated about a 12% improvement, which in some of the other research trials we've done implementing technologies, we tend to get pretty excited about a 3 to 5% improvement. This was almost 2 to 3 times that amount. And if we looked at it, we went back, and this information is on the BEI Ag Solutions website, but we looked at it in terms, when we pooled them together, obviously we saw the statistical differences at less than 0.001, but you can see in the turn by turn, in every situation we had better performance in the EPI control rooms compared to their cohort controls. So what did that average daily gain translate into? Those pigs started about 23 days wean age, so about 15 pounds. So that performance improvement allowed us to have about a 5-pound heavier pig in about a 42-day nursery run. Looking at the mortality and doing a chi-squared analysis on it, we saw about 1.2% total reduction in mortality over those 5 turns, and that was also statistically significant at a 0.001 level. Looking at the hydrogen sulfide emissions, as it was measured with some gas equipment that we had utilized and obtained through working with a group in Iowa State, was we saw a statistically significant difference at the 0.05 level on the reduction of hydrogen sulfide emissions. Or in other words, you say it's a 60% reduction. What the ammonia emissions look like? There we kind of saw the same thing. We saw about a 55% reduction in ammonia levels, and that was at a 0.001 value. Now we're going to look at the results of the dust particulate matter. We had a system of collecting dust at 3 different levels. You can see, now point out in blue. The blue there is particulate matter at 0.05 micron level. The red was dust particulate matter at the 2.5 micron level. And the green was dust particulate matter measured at the 10 micron level. And essentially what you see, when we look and do the stats of that, is we had essentially that 40 to 60% reduction in dust particulate matter. So very similar to the numbers that the USDA people have generated in looking at the poultry numbers. So we saw the indicators of how the mechanism works. We've seen a performance improvement. So based on that, what does the payback calculation look like? I mean, it looks really good, but we've got to understand what that payback looks like before you determine if that's something you're going to implement in your system. What we did, we've got a model that we used to our research data to help develop. It's kind of called the what-if model. It's just a production system model. So we took this information and put it into that model and tried to model it out to see what the payback would look like. So what you're seeing here is a representation in a 2010 nursery, which is essentially, that was the system that we were evaluating at that time in the research data. And what we took to be a little bit conservative is, you see for the mortality and then the average daily gain are here translated in the nursery eggs and weight improvement. We modeled that at 80% of the research results. We understand sometimes when you implement research results in the field conditions, you don't always get 100% reflection in return. So we took a little bit of a conservative estimate when we did this payback calculation. So if you model that out, essentially what that extra weight at the end of the nursery translated to the finishing and the performance, the mortality improvement, we wound up with a 37-cent cost reduction per 100 weight. And if you model that out, take that back against the initial cost of the EPI system, your payback period is 33 weeks on the system. So our implementation plan, based on the research that we saw, how repeatable, how consistent, what the payback model looked like, our implementation plan was to go ahead and put forward a capital appropriation request, which was approved, to put the EPI units in all company-owned nursery facilities. In addition to that, now that we understand and we've modeled, and we feel really good about what it does in the nursery, the natural evolution of that is, what does it do in conventional finishing and wean finish barns? So essentially, we're in the process of replicating that same sort of evaluation in 12 wean finish facilities in the Midwest to determine if the benefit, if we see the similar benefit in that type of system. We installed it in one of our R&D facilities, one barn out of 3, and we've seen 2 turns through those, and generally when we do those, we allocate the treatments equally amongst all 3 of those barns. Both times we've done that, we've seen the pigs coming out of that barns are 8 pounds heavier at the end of the wean finish period. But obviously that's nothing we want to run the stats on, but just kind of a casual observation. So a little bit more background if you want more information on the system. EEI, Baumgartner, and Byronics. John and Matt Baumgartner, they're here in the room today. They've got a booth set up in the tech tables. There's the website, eiagsolutions.com. And one thing I wanted to mention, obviously we were like everybody else. We had to make sure that we could replicate the results in our own system. And I know other systems have done the same thing. So in order to help facilitate that evaluation, they have donated one of the systems at the AASV. Actually, it's in the live auction now with free installation in the U.S. and Canada. That bidding will take place tomorrow night at the bank. So kind of in summary, the EPI system for us have demonstrated improvements in air quality, which translates into 12% improvement in average daily gain, or a 5-pound heavier pig in nursery exit, a 25% reduction in mortality, or 1.2% improvement in nursery mortality, 60% reduction in hydrogen sulfide and ammonia emissions, and a 40 to 60% reduction in gas particulate matter in the air. All that translates to 37 cents per hundredweight production cost improvement with a 33-week payback. So with that, at this time, I'll take any questions.